Well, hello everyone. I hope that you are doing well and good. This video is going to be about PySpark. And PySpark is nothing but the combination of SQL and Python. It is just like pandas, and it is very similar to pandas. And so, before watching this video, please make sure that you know SQL and Python both on an intermediate level so that you can understand the code. So, let's start with the code. First of all, we are going to import PySpark from PySpark.sql import Spark session. Please make sure that you have installed Anaconda, Navigator, and Jupyter Notebook. After that, you have installed the PySpark library on it. Then after that as well, you need to have the Java runtime as well. So like if you just search here, Java download, and you can see the download Java for Windows. If you click on here, then this symbol is of the Java and you have to download it and install it and then restart your computer. After that, you would be able to use this. Then you have to import OS and set environment library to the local host. Then import OS and system sys, some environment library executable sys executable. Then that's the main code. Spark is equal to spark session.builder.app name practice. You can write any name here, doesn't matter. Dot create, get or create. So that's the main syntax for Spark. After that, you need to configure it. This you may or may not have to do, but for me, I have to do it. So I did that. Like if it throws an error, then you need to Google the error and then you need to look for the solution for that error. You can also do the chat GPT if there is some error while invoking the Spark session in your system because it might throw a different kind of error. Now, let's move on to the def is equal to spark.read CSV, just like read CSV is there in pandas. Sample dot superstore. This is the CSV file where I have written the header is equal to true. So this will give me the all the headers with this of the CSV file, and it will only be showing in the top 20 rows of the data. That's all. From PySpark.sql.functions import star. Star means importing everything. So please make sure that you import everything from PySpark.sql.functions. Other than that, this sample superstore data you can also find on like Kaggle. You can search the sample superstore data Kaggle. Then you will find the CSV file for it and you can download it from there. Or otherwise, I will also provide the file in the description down below. Then we have the df.print schema. Print schema is nothing but it will just give me the data types of each and every column that's present in my data frame. So row ID is a string, order ID string, everything is in the string format because I have not given the infer schema, which I will just tell you. So let's df dot select row ID order ID. That's how we select columns here. We have to provide the column names in inverted commas. If you remember in pandas, then you have, if you like, you have to provide a multiple columns. Then you have to encapsulate it within the square brackets, and then you have to write a list inside. But in this case, you don't have to write a list. The syntax is like that. So now two columns are showing. Then let's say that you want to cast. I haven't infer schema in this one. I have casted it. I'm changing the order type of each and every column one by one. So df.width column row I df.width column. Then I am specifying the column name. Then I'm casting it to the data type integer. Basically, with column is a functionality that helps you add a column. Let's say you want to add a column into the data frame, then you would do with column, or even if you want to overwrite the column present or which is already present in the data frame, which I'm doing here, then also you do this. So I am just specifying that df.row id, casting it to the integer. Then there is order date. I'm casting it two date format, order date, and also providing the syntax, like it is in the format dd hyphen mm hyphen yyyyy. If you go up here, then if you see here, then it is dd hyphen which is month, and then year. Why? It is in this format, and whatever format is showing in your system, then you need to configure it like that only. Let's say it is showing like dd hyphen hyphen YY only, not YYYY, meaning like it is the 13, 24, whatever is the year. Then you have to specify YY. And let's say the month is in the front, then you have to specify month, then date, and year. So that you can choose. And with column, I'm overriding the column ship date to ddmmyy, converting it to daytime. So like afterwards, if you check the infer schema and you look at the order date, then it is the off type date which we have converted. Now, if we go back, then I have converted the sales, profit, discount, all to float, and the quantity to integer format. And then I'm taking a view over it, df.show, and it looks like that only. And you can see that the date format is changed. It is year, month, and date. So that is the default date format. Now I'm printing the schema just to look at whatever the data types of our columns are having after the conversion, after the casting. Okay, after that, now since we know that we have numeric value, then we can do some aggregations on it. We can group by. So I'm performing a group by based on category, and I'm taking the sum of sales and the sum of profit. Let's say in this case scenario, I also want to provide some aliases on that. Then there is another way which I'll show. It is an aggregated. So I hope that you are understood. I have just simply grouped it by category. Then I'm taking the sum of sales and the sum of profit, and then I'm just showing it. Now let's say, for example, I want to show the sum of sales and the average of profit. Then what I did is df.group by category, which is I'm taking, and then aggregated function. Please remember that you actually import everything from PySpark.sql.functions. Uh, uh, on above, basically we have imported everything, but still in this case I have specified like import sum, average, and round. But I would suggest that you please do import everything which is star. So now I have aggregated the sum of sales, and I have provided the aliases of that, which is the name of that, to sum of sales and the profit, average of profit, and also provided the aliases of that, the average of profit, and show. So that's how it is showing. I can also round it off if I want. If I can simply just I can write it round here, then I can provide aliases of it. That is also a way in which we can do. So then we have a where condition, where basically filters our data. And I just want to show the data where the profit is greater than 0 and the category is equal to furniture. So whatever the category we are having, let's say we have categories here, we have categories furniture, all the furniture are showing. You might be wondering like, oh, this format in which it is presenting itself, our data frame is presenting itself is like it's what is happening is the column is specified all over, then it takes to the second row because there is no space in front. So that's how it is. If it could come in this much space, then it would show me like that only. Okay, so don't get confused with that. It is just showing in two rows instead of one rows. Now df.select category comma profit, which I'm selecting two columns where I have provided condition where the df profit is greater than 0 and the category is equal to furniture, and I can also select whatever columns if I want to select from our data frame. And let's say I am doing pivot on the basis of category and ship mode. So ship mode, basically I have taken a pivot of whatever values we are having of it, it will come above, and we can do simply sum of sales and it is showing it. Let's say we want to do the sum of sales but we also want to round it off, then we can provide round sum of sales to the two decimal places, then we can do the aggregation of it. Group by pivot we have already done, so that's how the values that we can see. Moving on, we can also take the group by category pivot and aggregated values. Df.pivot. I have simply used a data frame which is df underscore pivot, just to take this data frame and put it inside a variable which is df pivot, because I just want to unpivot it. For unpivoting, what I can do is that I can provide unpivot. Then I can provide the column, then the column which needs to be the number of columns that are required to be pivoted in this case is first class, same day, second class, and standard class. So then we provide the name of the column that it will take after doing the unpivot, and the second key and value. So this is the key and this is the value. So whatever the values that we are having in this are converted into one column, and that column is ship mode. So basically we have taken the above thing and we have unpivoted it. Now, let's say, for example, we want to unpivot our data, but our data is having a lot of many categorical values, not just four categorical values, and we just don't know how many categorical values we have, maybe 20, maybe 200, maybe even more. We don't want to write each and every column value again and again. So for that, what we can do is we can take a select category distinct. We can select a distinct category. Okay. This is the category and this is the ship mode. Oh my goodness. Okay, I can even change this one. So this should be ship mode, and this one should be average of sales. Yeah, the sum of sales. This one should be the sum of sales. So we can change the value if you want, but I'm not doing it right here. Let me just do it. Okay. Uh, Ship mode. Sum of sales. Let's try it again. And it works. Great. So now that is how we unpivot our data. Hmm. Now we are taking the df category distinct. We are taking distinct values of it. I'm just to show you. That's how we can show it. We can take the distinct values of that category and we can convert it to pandas. After converting to the pandas, then we can select the column which is category, and we can list that column, because we cannot list a PySpark data frame column into a list, but we can do that of panda. So what I've done is converted the PySpark into the pandas, and I have converted back that to the list format. Now I can simply specify whatever list that I have provided above as here. So in this scenario, I don't have a static value, I have a dynamic value, and again the same thing I have done by, okay, let's just remove this and put a comma here and comma here, and sum of sales, sum of sales, commas, and yeps. So that's the same one pivot, but in this one I have taken the dynamic values. Then our df dot show, just to show our data frame again. Moving on, let's say for example, I just want to add a column revenue, which is the sales multiplied by quantity. Now let's say that I want to make another column revenue, which is basically the sales multiplied by quantity. And what I can do is that I can select the two columns if I want to select, and then with column which will add another column, and sales multiply by quantity, like that. If I show it, then it will be showing me the value. Now let's say for example I want to write the SQL code syntax inside my PySpark. What will I do? I can create or replace temporary view. So I can create a SQL view kind of syntax and name it as df.sql. So now a temporary view is created. Spark.sql, select star from df underscore sql, then show. Then it will also show me everything because that's the statement, select everything from this table. So that is also how we can provide a table, and we can also do spark.sql select category round off sum of sales as sum of sales from the table group by category. Simple sum of sales and group by and rounding off Spark SQL. So just to show that we can also provide an SQL statement like that. Okay. Now moving on to the concat and lit. Let's say for example, I want to concat two column values, which is category and subcategory, with a symbol which is a plus sign. Then what I can do with column, name the column, concat it, dear dot category comma let basically what let does is, let's say for example, if I haven't provided let but I have simply provided the inverted comma plus, then it will not perform the operation because that does not do each and every uh, it does not iterate in rows. It basically will throw an error. So what it does is it just concatenates each and every string at each and every row, and with each and every row that we want to concatenate. So that is how it is done. And the truncate is equal to false I have done. Let's say for example, if I haven't done it, then it will, like, let me just show you directly. If I simply do that, then it will do plus and dot 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 dot, which I do not want. So Control Z and Shift Enter. Then that's basically, I'm not truncating anything. So that is why truncate is equal to false. Truncating is the thing that you saw was truncate. Anyhow, from PySpark.sql.function import year comma month. So that's what we are importing, and with column year of date, year of order date, okay, and we have taken year of order date and show. That's how we take the year of order date, and let's say month of order date, and the month will show the numbers. Let's say if I want to format the month of order date by date format, then I can simply provide that, and m 3 times m, which will give me the short date, and 4 times m will give me the long date, which is the January, January. In the uh, short month, it will just give me the Jan. I hope you understand. Then similarly, we can do a date format of YYYY by year. That is how we can specify the year. And then I have taken another column as well, which is the month number of the order date, which is basically mm. Is the month number. So this will give me the month number basically, which is 01 of January. And yeah, so I have simply added 3 columns: month of order date, year of order date, and month of order date. Why? Because I want to, I'm just showing it again. I can also drop column dot drop by providing the column and overwriting the column. That's how we drop it. In pandas we can do in place, but in this one we don't do that. Okay, so now I just want to group it by month in the rows and year in the columns. So group by month of order date, pivot, year of order date. So that is in the rows and that is in the columns. Aggregated values, round of average of sales. So these are the average of sales rounded to the 2 decimal places. Then I have sorted it on the basis of month of order date. And if I sort it on the basis of month of order date, then you can see that it is sorting it by ascending order on the basis of the name, but not on the basis of month. So for if I want to do it on the basis of month, then I have to take another column of month number, and then I have to sort it on the basis of that. Then it will show me the Jan, Feb, March, and so on. Similarly, I can take year on the x-axis or the rows, and the pivot on the y-axis or the columns, and this the same aggregation average of sales rounded off to two decimal places, then sort on the basis of order date, year of order date. So this, yeah, that is how we do it. Now let's say, for example, I have to sort it on the basis of month number. Then I can do I have to specify another column for that. Then I can, if after doing all that, I can select the required columns I want. And if I don't want to show all the columns, I can simply select whatever the columns I want. Now df.group by, that's another example. The same thing on yeah. So let's say I just want to sort it in the descending format, then ascending is equal to false. As simple as that. Now let's say, now we are taking the employees database. Previously we have taken Super Samba Superstore. Now we are taking the employees database. Employees database we have taken because we want to perform some joins, which you will see in a minute. I have taken the infer schema, which will basically detect the data types of the columns which are present inside our data frame. Then I have taken the salaries, headed is equal to true, infer schema is also true. All these are CSV that I have provided. Departments, department employee, department managers, and titles. I hope that you are aware of this because I have explained this one in my previous video in the sequel. But just to recap it, I have to explain you a little bit. Let's go back to the MySQL. In case I want to run it like that, I can run it like that. So employees is employee number, birth date, first name, last name, gender. Yep. So, and hire date. And in salaries, we have the employee number, salary, from date, and to date. You can see that one employee number can have multiple salaries because their salaries increment. And the employee number is only one, the name can only be one, birth date can only be one, last name, and all these things can only be one. Repeating only one times. Now department managers, employee number, department number, from date to date. Departments, these are the departments, these are the department name, department employee, that's the employee number, department number, from date and to date. And then titles, employee number, whatever the title he is having, senior engineer, staff engineer, or assistant engineer, or so on. All right, so that's the recap. Let's go back. Now I have printed the schema just to see whatever infer our schema, our data was able to do. It was able to detect a date type because it was in the right format, which is year, month, and date. So it is done for all the columns for employees, salaries, department employee, department manager, titles. These are the 6 tables that we are having. Now let's say that we want to perform join on the basis of employees. I'm joining salaries. I'm doing the left join because the salary is repeating, and if I do the left join, then the left side of it will also repeat. And even if I did the inner join, then also the output would have been the same. I'm not doing any aggregation here. I can also perform some aggregation. Let's say I'm taking either salary, employees, aliases. I can also provide some aliases of the employees if I want to provide. Salaries I can provide as, then employees or employee number is equal to salaries or employee number. I perform the left join. Black backslash I've taken for the next line. Let's say I don't want to show everything in this line. I want to show the rest of the code in the second line. I can do that by providing the backslash. Then group by I have taken this, aggregated by group by I have taken e dot employee number. I can also provide like employees dot employee number like that. I can also provided it in the single quotes. Then I have aggregated a round of average of salary to two decimal places, renamed it by average salary. So for every employee number, I have taken average salary. As simple as that, into a table which is e salary. I'm showing that table. Now, what I can do is that I can take an employees and I can take the average salary of each and every employees. We know that the salaries in salaries employee number was replicating because for one employee there can be many salaries. But I have aggregated all the salaries on the basis of the employee number. So now, if I join that back to the employees table, we can observe that only one value is taken for each and every employee. So by default, that is happening which we wanted. Now yeah, so I have performed the join left and select, we can also select employees star. That's how we select everything from the employees table. And average salary I have only taken from the second table, e underscore salary. I haven't provided any aliases to that. If I want, I can provide aliases like this. Order by on the basis of employee number dot employees dot employee number. So it is ordered by on the basis of employees dot employee number show. That's how it is shown. Now let's say for example I want to do the Spark SQL code for the entire thingy, and I have taken created a view and named the view the same as the table that I have allocated. So for create or replace temporary view, it has taken employees and taken that into employee, salaries to salaries, department to department, and so on. And now I can perform a SQL syntax like that. In that spark.sql, I have provided three quotes, which implies that I can do multiple line comment here. So that's the multiple line comment, which is basically our SQL statement with CTE, and I'm showing it. So basically what I wanted is I wanted to select employee number, birth date, average salary, department name, title from employees. And these are present in different table, and I'm taking the aggregation of those table and then joining them. Let's go back to the MySQL for better understanding. So with CTE, common table expression, select everything from select employee birth date from employees. So we only want that from this table. Let me execute this one. That is how it is looking. Employee and birth date, simple selection, nothing too fancy. Then I have taken another query. With CTEs act like a subquery. I have explained that in my video, but for here I'm just showing you the main concepts. Now, if I execute a second statement, which is simple round average salary as average salary from salaries, and if I do it now for every employee, we are getting the average salary rounded off to the two decimal places. Now for the third case, I have taken the department employee numbers and I have merged it on the basis of departments. Let me just show you. If I execute it, for every employee number, there is a department name which was present in the departments table. On the basis of department number, I have joined the table. If you want to see it again, then maybe what I can do is I can execute these three and I can cross this middle one and which departments were there, but I think I can also show the departments as well. Let's just execute again. So departments managers, employee number, department number from date to date, departments number, department name. In here we only have the department number. We just want on the basis of every employee department name, which we have taken the join and merged it, and we got the department name. Then I have selected department employee number and department name from department manager table, and similarly I have done from the employee department employee table. Because both of them were having the same number of columns, I can also provide union of it, which I did. Then it will merge the employee number of the employees and the managers, Then after that, I can simply take the CTE4, in which I can simply take the titles from the titles. If I execute this one, then for every employee number, we have the title. Now, four CTEs, four subqueries basically, and now we can provide the SQL syntax. So select CT1 everything, which is basically employee number and birth date. Then CT2 average salary, because employee number we already had. CT3 department name, because everything else we already had, and we just want the employee number, birth dates, average salary, department name, and title from employees. Then C4 we have taken titles because employee number we already had, and all that we have joined from CT1, join CT2 on the ID, join CT3 on the CT1 ID, and join CT4 on also on the CT1 ID. So I have taken CTE1 table, which is the employees table. On the basis of the employee ID, I have joined all the tables. And if you can make some idea in your head, then you may notice that in our this table CT1, which is employees table, is our fact table, and other tables are just connecting in a star schema on that fact table. So like on CT1, 2, 3, and 4 are connecting. So three tables are connecting on the CT1. In total, we have four tables. Yes. And that's the entire syntax of it, which I have explained, and it runs perfectly well. And if I execute it, then we have all received all the records, and we have employee number, birth date. Okay. You may notice that that person may also be a staff and a manager. Impressive. Manager, senior staff, and staff. That is also nice. So title is replicating. Anyhow, we have 166620 records in this one. All right. So now we can go back to this, and I have simply copy pasted it here and executed it. If I see this one, I can observe that we are having all the records, and we will go down, we will check all the records again, but wait a second for that before. Now I have to implement the same logic using the PySpark or the Python technique. Basically, CT1 is equal to employee, select employee and birth date, which we did in CT1. CT2, we have taken employee number and average salary. CT3, we have taken the department one, which is equal to employee and department manager. Then I have also unionated it. Basically, does do I also did the union, and after union it, I have kept that in the C3, which we did before, and that is how it looks. Now we have a name, department name for each and every employee, and that's how it does. Okay, now that is good. Then we have title, and title can be replicated as we have noticed. And this was simple. Select, we have simply done the select statement. This was a little bit complicated because we have to perform some join, and I haven't provided any join query because by default it is inner join, and which is what we wanted. Moving down, uh, yeah, so we did the union, we did the CT4, then CT1.CT2 join we did just to show, CT1, CT3 join we did just to show. And now the final select statement, which is CT1 join CT2, join CT3 on the basis of 1, join CT4 on the basis of 1. And all that we can select whatever columns we want, CT1 employee number, CT1 birth date, CT2 average salary, department name, and title. That is all what we wanted, and that is all what we have taken. Not show. Now that will show us everything. Now let's say, for example, I copy this, paste it here, and instead of showing it like that, I can also. So after doing this, I also just took the count of it and I can see that it is 1,666,2,0, which is the same number of rows that we are getting here. So basically I have to just take it count and I don't have to show it. Then this is 1,666,7,4. That's the number of count that we are getting here, and number of count we are getting here is 20. Something is fishy is going on. We don't know what. We will see. But anyhow, it is very similar and very near. So that is all for this video. I hope you liked it. Thank you for watching. Bye bye.